Hey everybody, this is Mr. Ainsworth, and we're going to get into your Chapter 9 test review. Alright, so I have the following things ready, okay? You need your notes, okay? So I would suggest you get all your notes out, number one. Number two, calculator. Get that out. Step three, get your note card out with all the facts on it. Alright, get prepared. Get a red pen out. Four, red pen. Alright, and if you need to annotate important things in red, do it. Be smart, be wise, be a good reviewer, okay? Know your strengths, know your weaknesses. So get your notes out, calculator out, note card out, and get prepared before you even begin this. All right, be smart, be wise. Okay, so here we go. Now remember, this is also a video, okay? So you can always pause and play. And if I go too fast, well, pause it, rewind it, and listen to it again. All right? It's a video, so use it wisely, okay? Pause, play, and rewind. So pause, all right? Play and rewind as needed. All right? Use it as a video. All right? Use it as a good resource. Okay, so here we go. All right, show how to find. Show. That means you actually have to show. You can't just state the answers. All right, so understand that. You got to show how to find the next three terms. Well, in this recursive relation here, recursive rule or recursive relation, however you want to state it, a sub n equals 3 times the previous term, which is called a sub n minus 1, plus 2 more. All right, so a sub 1 is 2. That's called the seed, first term, or what's called the initial, all right, term. That's called the seed. You got to start from something, right? Okay, so the first term is 1. A sub 2 is equal to 3 times the previous term, so 3 times the previous term plus 2. So you got to bring in your previous term. Previous to A2 is A1, right? The first term is before the second term, so think simple. 3 times 2 is 6, plus 2 is 8. All right? A sub 3 is 3 times the previous term, 8, plus 2 more. So you got to bring that in. All right? Whoosh, right there. Put in the sound effects. All right? And then you got 3 times 8, 24, plus 2, 26. Okay? A sub 4, well, that's 3 times the previous term plus 2. Bring it in right here, 26. Now, if you don't want to do it on your head, okay, like I like to do, I like to do it in the head. Come on. You gotta love the technology here. I'm just too fast for it, okay? I need a Pentium 4 or something like that. No, that's old technology. I need like a Pentium 1000. That's what I need. All right, 3 times 26 plus 2 more. All right, type it in, get it. You got 80, right? 60 and 18, 78. All right, plus 2, 80. All right, no problem. I can do it in my head. I just wanted to show you. All right, so remember what this means. This means previous term. All right, that's what it means. 3 times the previous term plus 2. N minus 1 is previous to n. Why? Because you subtract 1 from it. The fifth term is, well, the previous term in the fifth term is the fourth term. 5 minus 1 is 4. All right, next problem. Okay, let's go through this bad boy. This is your test prep, all right? Take it seriously. Given the sequence, find a sub n and the next two terms. So you have to find a sub n and the next two terms. You got to do two things. Read the directions. All right, how do you do this? 1, 5. So you add 4, then you add 4 again. Ooh, that doesn't work. It's not arithmetic. Okay. It's because, you add 4 here, and then you add 1. So, oh, not arithmetic. Okay, so what do you do? Well, let me see. We've been studying Fibonacci numbers this entire time for the last, I don't know, 3 weeks. Maybe it's a Fibonacci-like sequence. I don't know. Maybe if we add these two terms, 1 plus 5, you get 6. 5 plus 6, you get 11. 11 plus 17, you get 28. 17 plus 28, you add, okay? Add, okay? 17, 28. 30 plus 15, 45. All right, 17 plus 28, 45. 28 plus 45, you get 60 and 11, or 16, 13, 73. 73 here, okay? See, if this is a sub n, all right, this is a sub n minus 1, this is a sub n minus 2. All right, you add these two and you get this one. So a sub n equals a sub n minus 1 plus a sub n minus 2. That's all there is to it, guys. Or you can reverse this. It doesn't really matter. You can say a sub n minus 2 plus a sub n minus 1, however you want to say it. Okay? Either one. It doesn't matter because in addition, the order doesn't matter. You add the previous two terms. Add the previous two terms. Oops. Two terms. All right, to get to the next one. That's the idea. All right, given the sequence, find a sub n in the next three terms. Same idea. So what do you have on this one? I don't know. Well, I do know. Okay, so let me see. You try addition first, right? Okay, so you add 5, add 5. Oh, here you add 15. Okay, boom, boom, not arithmetic. Okay, so it's not arithmetic because there's no common difference. Do you multiply by something to get 7? Probably not. Do you multiply 7 by something to get 22? Probably not. So it's a combination, right? So what do you add? What do you multiply 2 by to get close to 7? Well, let's try times 3, right? 2 times 3 is 6. Oh, you got to add 1. Okay. 3 times 7, 21. Add 1, 22. Oh, so times 3, add 1. So enter it on your calculator. 67 times 3 plus 1. 202. So 202. Once again, you times 3 and add 1. So you already have it on your calculator, right? So you go times 3, add 1. It's that simple. Times 3, add 1. It's 607. 607. So what you have to do is you have to take your previous term, a sub n is equal to 3 times your previous one, and then add 1. That's your recursion. All right, you're happy if you got that. All right. State the first 15 Fibonacci numbers. Okay, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. All right, 233. I don't know, 377 looks like. All right, 610. All right, and you get the first 15 Fibonacci numbers. This is F6, F7, F8, F9, F10, F11, F12, F13, F14, and voila, F15. All right. Okay, state Benet's formula. Okay, that's all right. Define F sub n. All right, the nth Fibonacci number. Nth Fibonacci number. Okay, so F sub n is equal to 1 plus the root 5 divided by 2 to the nth minus 1 minus the root 5 divided by 2 to the nth divided by root 5. Okay, that's all there is to it. Now the best approximation for this, all right, F sub n is approximately equal to phi to the nth divided by rad 5. All right. State phi, the golden ratio. Well, that's 1 plus root 5 divided by 2, and that's approximately equal to 1.618. Ooh, okay. All right, so what's F28? What's F34? Okay, let's figure this out. All right, clear out your calculator. Take 1 plus the square root of 5. All right, enter, divided by 2, enter. There's your phi. There's phi right there. Now you got to raise it. Let me stop. This is phi to approximately equal to phi to the 28th power divided by rad 5, rounded to the nearest whole number. I'm not going to use Benet's form. I'm going to use the best approximator. Okay, so I need to raise it to the 20th power, raise it to the 28th, and then I have to divide it by root 5. 317,811. So 317,811. Okay, what is this one? Well, it's phi to the 34th divided by rad 5. Let's figure this out. Let's clear it and let's do it over again. So 1 plus, whoops, come on, clear. Ooh, come on, come on. Clear, baby, clear. Okay, let me wait till my technology catches up. Clear. There we go. 1 plus square root of 5. See, you can't enter in 1.618. Okay, that doesn't work. It's an infinite decimal, so you can't just use the first 4 digits. You got to use all of them, all right? Divided by 2. Calculator carries 32. 10 that you see and 22 in behind in its RAM, okay? Now you got to raise it to the 34th power. Boom. Raise it to the 34th power. Divide that baby by root 5. All right, and you get 5,702,000. Or no, yeah, that's right. So 5,702,000. What? 887 right here. 887. So it's a big number. What's F50? I don't know. It's probably really, really big. Okay, so 1 plus square root of 5. All right, divided by 2. All right, raise it to the 50th. All right, now you're in exponential notation here. Divided by the square root of 5. All right, we're still in exponential notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're missing a digit. So it's approximately equal to, you know what? I'm going to do this. Watch this. You're going to love this. Woo. Okay. I need a mouse. Come on, my pointer here. Aha. Ah, okay, I need to move it. There we go. Nice. Okay. Come on, move. Sorry, guys. My computer's acting a little bit slow right now. Okay, so hang on. Okay, so what we have here on this one here, it's 1. You got to move the decimal 10 places to the left. See this right here is times 10 to the 10th, right? Because it says E. E10 means exponential notation. You have to move the decimal 10 places to the right. So it's 1, 2, 586, 586. All right, 269, 269. All right, 0, 3. So 0, 3. So I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, right there. Put in your commas. Boom, boom, boom. All right. So we got 100,000s, we got millions, billions. So 12,586,269 and 30. Ooh, that's a big number. All right. What is F4 minus 3 times F4 minus F8? Well, let me see. 1, 1, 2, 3, 5, 8, 13. 1, 2, 3, 4, 5. So this is F4. 6, 5, 6, 7, 8. This is F8. Okay, so here we go. So 3 times 3. So 3 times 3 plus 21. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here we go. 9 plus 21 is 30. All right, there we go. Boom, right there. Okay, so what's all this? So it's negative 5 times something minus something. I got to find F11 and F12. So what do we do? F11 is 89, F12 is 144. So 89, 144. All right, and then you type it in the calculator. Okay, this is not that hard. So -5, let me clear it out here. So -5 times 89, all right, minus 144. -589. So -589. Ooh, better write that better. Okay, and what is this? Let me see. F8. What's F8? So F8, it's right here, 21. Okay, no big deal. So what's 21 to the third power? Use your calculator, right? So bring it on. So 21 to the third power. Let's clear that out and let's try that again. 21 to the third power. 9,261. So 9,261. Okay, let's move on. Okay, number 12. Okay, is G a gnomon to A? Well, if it is, all right, if it is, then the ratios of corresponding sides of the similar figures are the same. Then basically A, let me say it in simple terms, is similar to A and G. That's what it means. See, you have two triangles here. You have a small one inside a big one. All right. Hopefully you guys see two triangles here. I hope so. Now the big one, or the small one, is 6 by 10. 6 on the left, 10 on the base. The big one, well, that's 8 on the left side and 16 on the base. All right, 16 right there. So it has different dimensions. Well, if they're similar, that means the ratios are the same. Ratios are equal. All right, left side to base, left side to base. Or you can go left to left, base to base, however you want to do it. There's two ways to do it. I'll show you both. If you want to go left side to base, left to the base, this is how you do it. You go 6 to 10 on A, 6 to 10, and then you go 8 to 16, 8 to 16. This is 3/5. Oh, and this is, if you divide both by 2, you get 4. Oh, divide both by 4, you get 2. Oh, you get 1/2. What am I doing? 8, 16. Yeah, that's right. You get 1/2, and they're definitely not equal, and these aren't equal. So already I can tell that G is not, all right, a gnomon, gnomon to A. Or you can go left to left. Go A to A and G. Okay, so 6 to 8, left to left. 6 to 8, left to left, and you go base to base. All right, 10 to 16. Now here you get 3/4, and here you get divided both by 2, you get 5/8. And they're not equal either. Why? Well, let me see. That's 20, that's 24, and they're not equal. The cross products aren't equal. So G is not a gnomon to A because the ratios are not equal. If they were equal, then they would be similar. All right, that's all there is to it. For every two similar figures, that's the case. Like on this one, if you go length width, all right. So on A, that's let me see, 14 to 8, 14 to 8. On A and G, A and G. All right, that's 21 to 12. So 21 to 12. Let me see, let's reduce. So 7/4 here, divided by 3, 7/4 here. Ooh, they're equal, they're equal. So G is a gnomon to A. All right, that's all there is to it, guys. It's that simple. Now, if I went too fast, rewind it, okay? Don't go on to the next one. Rewind it, listen to it again. All right, here we got to find x. All right, so here you got a rectangle A inside a bigger rectangle. All right, that's, whatever this is by 16, right? A and G combined. So A and G is this big rectangle in red. A and G combined. Okay, so watch this, length to width. So for A, it's 16 to 4. For A and G, it is 4 plus x to 16. Long to short, 4 plus x to 16. Let's cross multiply. So 4 times 4 plus x equals 256. Use your calculator to check. Okay, distributing. Subtracting. 240. Dividing. There you go. So x has got to be 60. So this is 60 units from here to here. All right. That should make sense because if you multiply this by 4, this total length would be 64, right? 64 minus 4 is 60. There you go. I taught it 2 different ways. Okay, on this one, same thing, length to width. So for A, it's 8 by 5. For A and G, I don't know, let's figure that out. All right, so we got 2, 5, and x. That's 7 plus x. This way, right here, we got 3, we got 8, and we got 6. That's 6 and 8, 14, plus 3, 17. So on this one, we got 17 by 7 plus x. Okay, now cross multiply. So we get 8 times 7 plus x equals 50 and 35, 85. 56 plus 8x equals 85. 8x is equal to 85 minus that. 29 maybe. I don't know. Let's see. 29, 70, 85. Yeah, that sounds right. Okay, divide by 8. X is equal to this. All right, and we go 3 times 8 is 24, remainder 5, so 5 eighths. All right, 29 divided by 8, 3 and 5 eighths. Do the math. Okay, number 16. What does it mean to be a G? What does it explain what it means for G to be a gnomon A? Well, if G is a gnomon to A, then, well, let's see. A and G is similar to the original figure A. That's what it means. All right, get it down. Okay, that was from the very beginning. All right, if you have a rectangle and then you add a one-sided gnomon to it, or actually a two-sided gnomon or whatever you want, all right, and you get a bigger rectangle like this, you got A here, you got gnomon here, and this is A and G combined. All right, this is similar to the original. A and G is similar to A. That's what it just said in the definition. You can do it with triangles too, by the way. So you got a triangle here plus the gnomon, which is like this, you know. So you get a bigger triangle here. All right, same thing. So A, G, A, and G. I've been talking about it for a week. Let's get it down, people. Okay, here we go. On a golden rectangle with the width is 5.4 centimeters, what is the final length? Well, I know the length width ratio is 1.618, right? So the length is equal to, well, let me see, if I multiply both sides by W, so 1.618 times W. So the length here is equal to 1.618 times the width, which is 5.4. It's a calculator problem, right? It kind of sounds like it. Okay, let's do it. So 1.618 times 5.4. All right, 8.7372. So 8.7372. Let me check. Oh yeah. All right. Centimeters. All right, it's longer than the width. Longer than the width. Why? Because the length is always longer. Okay. Now on this one here, the length is 6.8, so L to W equals 1.618, right? So you substitute the length in, so you get 6.8 to W is equal to 1.618. All right. Well, multiplied by W, get 6.8 equals 1.618 W. Divide by 1.618, divide by 1.618, then W is equal to 6.8 divided by the golden ratio, 1.618. You do that on the calculator. All right, 6.8 divided by 1.618, and you get 4.202, so 4.202 inches. All right, now you have a 5 by rectangle. Is it golden? Let's check. Length width is, all right, this equal to phi. That's the big question. So 8 divided by 5. All right, let's do it. 8 divided by 5. Oh my God, it's 1.6. 1.6. All right, not equal to 1.618. Not golden, but close. All right, there we go. All right, next one. Give 2 examples of Fibonacci rectangles. Let me see. Well, the first thing you have to do is you have to generate the sequence, right? 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. This is the Fibonacci sequence. So one rectangle, all right, one of them would be 5 by 8. 5 by 8. Another one would be 21 by 13. So 21 by 13. You got a lot of examples, okay? Pick 2 consecutive rectangles, okay? Numbers must be consecutive, okay? Numbers must be consecutive. And if you don't know what that means, it means one right after the other. Okay? There you go. Draw the Fibonacci spiral. That's easy too. Okay, so here we go. I'll just draw a part of it. So you start off with a 1 by 1 square. I'm going to shade it in. You add a square to it. You get a 1 by 2. Then add a 2 by 2. And then a 3 by 3. So 2 by 2, 3 by 3. All right, and then a 5 by 5. 1, 2, 3, 4, 5. 5 by 5. Notice their numbers in the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, so on. So here we went down, right, up, left, down. 1, 2, 3, 4, 5, 6, 7, 8. No, 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 no. It's an 8 by 8. All right, and then a 13 by 13. Why? Because 2, 3, and 8 is 13, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, 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 no. No, 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 no. 13 by 13. Then you draw your spiral. All right, so here we go. Quarter circles. Okay, all of these are quarter circles in the square. That's how you do it. Okay, number 22. If R2 is bigger than R1 by a scale factor of 5, find R2 of it. If R1 is 8 by 14, so R1 is 8 by 14. Scale factor is 5. So, okay, equals 5. R2 is bigger because it says so. All right, so let me see. 8 times 5 is 40. 14 times 5 is 70. That tells me it's a 4 by 70 inch. All right, that's R2. You guys, this is not too hard. Okay, now if the area of R1 is 80, so R1, 80 square inches, okay? The area R2, R2, R2 is bigger. All right, so you got to times not by k, but times by k squared. So times by 6 squared. All right, so that's 80 times 36. What is that? So 80 times 2880. So 2880 square inches. All right, that's the key right here. Times by k squared for the area. This is an area problem, not a dimensions problem. Look in your notes, we did the same thing. See, what you guys got to realize is that reviewing is essential because you can't remember everything. Okay? Now you have to review. Like on proportions, you got to cross multiply. All right, so 7x is equal to 3 times x minus 4. 7x is equal to 3x minus 12. That means 4x equals negative 12, and that means x is negative 3. Simple. Over here, a little bit more challenging. All right, you got to cross multiply here. All right, so let's do it. You got x times x minus 4 equals 16. X squared minus 4x equals 16. Set equal to 0. Minus 16 minus 16. You get x squared minus 4x minus 16 equals 0. Use the quad formula. Okay, a is 1, b, c. So x is equal to the opposite of b, 4, plus or minus square root 16, negative 4 squared is 16, minus 4 times a times c, divided by 2 times a. What do you get? You get 4 plus or minus square root 16 plus 64. This is 64 here. 16 plus 64 divided by 2. 4 plus or minus the square root of, let me see, 70, 10, 80 divided by 2. So you get x is equal to 4 plus or minus the square root of 80. No, I got to simplify the square root of 80. See, 80 is square root of 80. Square root of 16 times 5. All right, forward 5. So forward 5, all divided by 2. So you get 2 plus or minus 2 add 5. All right. How do you simplify roots? Well, root 8 is root 4 times root 2, which is 2 add 2. Root 12 is root 6 times, no, not root 6. Root 4 times root 3, which is 2 rad 3. And this is root 4 times root 10, which is 2 rad 10. All right, your goals, these three here, guys. And the last one, here we go, last calculator problem. Okay, calculator. All right, calculator. Okay, so let's do it. Okay, so here we go. Now remember, phi. Remember phi. The golden ratio. All right, so what do we have? We have 1 plus root 5 divided by 2 to the 7th power divided by root 5. What is that approximately equal to? Well, I know it's F17, but what in the world is that? So if you don't remember what it is, obviously use the calculator. 1 plus the square root of 5. All right, divide that by 2. There's phi. Let's start over. Come on, catch up. So 1 plus square root of 5. All right. I'll tell you, my computer is really lagging. All right, 1 plus, there we go. Oh, see, when I'm trying to record a video, sometimes my computer is a little slow because it's working hard. 1 plus square root of 5. I'm going to start over. Divide that by 2. Take it to the 17th power. All right, divided by root 5. There we go. That can't be right. Okay, let me start over. 1 plus square root of 5 divided by 2. Whoops, that's not it. Come on, you got to press the right buttons. Let me start over. I apologize. You know, calculators are great, but you got to press the right buttons. Okay, so you got that divided by 2. There's phi. Now let's raise it to the 17th power. There we go. Divided by root 5. Now round it. 1597. There we go. Okay, that's actually, just to let you know, that's f sub 17. Alright, this one's f33. I don't know what that is though, so let's figure it out. Alright, so let's figure it out. So 1 plus, let me clear it out so you can see it better. 1 plus, I keep doing the same thing, guys. You got to practice this. After a while, it becomes a piece of cake. Divide that by 2. Raise it to the 33rd power. Divided by root 5. Alright, and you get 3,524,000. So 3,524,000. 578. 578. Alright, what is all this other stuff? I don't know. Phi to the 20th. So 1 plus the square root of 5 divided by 2. There's phi. Now I got to raise it to the 20th, and I'm done. Alright, and so 15,126. So 15,126. Why? Because I'm rounding to the nearest whole number. Okay, so this is f8 minus f5. So f8 minus f5. What is that? 1, 1, 2, 3, 5, 8, 13. 1, 2, 3, 4, 5, 6, 7, 8. So it's 21 minus 13. Alright, it better be 8, right? Okay, I didn't use a calculator, but man, that was cool. Alright, there you go. And that is it, my friends. That is it. Alright, do your best. And I'll see you next time. This is Mr. Ainsworth signing off because I'm tired. Bye-bye.